July 14, 1944, 3 miles southwest of Saint-Lô, France. Lieutenant General Omar Bradley stood with his arms crossed, watching a Sherman tank back away from a hedgerow that had stopped American advances cold for 6 weeks. Around him stood a small group of officers, including Major General Leonard Guerreau, commander of 5th Corps, and several ordnance specialists who had been summoned to witness what might be either a breakthrough or another failed experiment. Welded to the front of the tank were 4 steel prongs that jutted forward like tusks, a contraption so simple that Bradley had initially dismissed the report when it first crossed his desk. But desperate times demanded desperate measures, and the American breakout from Normandy hung in the balance. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. The tank's engine roared to life. The driver shifted into gear and accelerated directly at the ancient earthen wall. 10 miles per hour. 15. The steel prongs struck the hedgerow with a sound like tearing canvas, a noise that would become familiar to American tankers across France in the coming weeks. Earth and roots exploded upward in a fountain of dirt. The tank did not climb or tilt. It drove straight through, its prongs cutting into the base of the hedgerow like enormous knives through tough fabric. And then, in less than 5 seconds, the Sherman burst through to the other side, trailing broken branches and torn vegetation, but otherwise undamaged, its belly armor never exposed to enemy fire. Bradley's staff officers erupted in cheers. Ordnance specialists scrambled to examine the hedgerow, measuring the breach, checking for damage to the tank. The general himself remained silent for a moment, his mind already calculating the implications. If this device worked reliably, if it could be manufactured in quantity, if it could be installed on enough tanks before the planned offensive, then perhaps Operation Cobra could succeed. Perhaps the stalemate could be broken. He turned to Lieutenant Colonel John Medaris, his chief ordnance officer, and spoke words that would change the course of the war. I want these devices manufactured and fitted to as many tanks as possible. Every Sherman, every Stuart, every tank destroyer we can modify. I want them ready before Operation Cobra launches. Round-the-clock production, use every ordnance unit, every maintenance depot, every welder we have. This is top priority. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. What Bradley had just witnessed was the solution to a problem that had threatened to turn the greatest amphibious invasion in history into a bloody stalemate. For 6 weeks, the bocage of Normandy had defeated the most powerful army ever assembled. The hedgerows, ancient boundaries between Norman fields, had proven more formidable than German concrete fortifications, more effective than minefields, more deadly than the Atlantic Wall itself. And the man who had solved this seemingly impossible problem was not a general with decades of military experience, not an MIT-trained engineer with advanced degrees, but a 29-year-old sergeant from New Jersey who had improvised a solution from scrap metal salvaged from German beach obstacles and applied nothing more complicated than common sense and a welding torch. This is the story of how Curtis Coulin's simple invention broke the Normandy stalemate and opened the road to Germany. 300 miles away, Supreme Commander Dwight David Eisenhower paced in his headquarters at Southwick House near Portsmouth, studying maps that told a story of mounting disaster. It was mid-June 1944. The D-Day landings, executed just days earlier, had succeeded beyond even the most optimistic projections. Despite horrific casualties on Omaha Beach, where American forces had nearly been thrown back into the sea by nightfall of June 6th, more than 150,000 American, British, and Canadian troops had established footholds along 50 miles of French coastline. Within a week, the Allies had landed over 300,000 troops and established a continuous beachhead from the Cotentin Peninsula to Cayenne. The greatest amphibious assault in history had breached Hitler's Atlantic Wall. The fortress Europe that Nazi propaganda had declared impregnable had been penetrated. But the maps told a darker story. Yes, the landings had succeeded. The beaches were secure. Supplies were flowing ashore through the 2 Mulberry artificial harbours, and directly over the beaches. But the advance inland, the rapid exploitation that was supposed to carry Allied armies deep into France, had stalled almost immediately. By mid-June, 2 weeks after D-Day, Allied forces controlled a beachhead barely 20 miles deep and 50 miles wide. More than 1 million troops were now ashore, but they were wedged into a narrow coastal strip, unable to advance, bleeding casualties by the thousands every day, and facing the very real possibility that the entire invasion might collapse into the same kind of static trench warfare that had characterized World War I. The grand strategy, carefully developed over 2 years of planning, called for rapid breakout from the beachhead. British and Canadian forces would seize Caen, a critical road and rail junction, on D-Day itself and push south into open tank country. American forces would cut across the Cotentin Peninsula, capture the port of Cherbourg within 9 days, then wheel south toward Brittany. Within 2 weeks, the Allied penetration was supposed to extend 15 miles inland along a continuous front. Mobile warfare, rapid exploitation, armoured thrusts deep into German rear areas. This was the vision that had guided planning. Instead, the Allies were bogged down in brutal close-quarters combat, advancing by yards rather than miles, losing thousands of men for tiny gains in territory. And the reason had a name: the bocage, the hedgerows of Normandy. June 7th, 1944. 24 hours after the successful landing on Omaha Beach, soldiers of the 1st Infantry Division, the Big Red One, pushed inland from the coast. They were exhausted from the beach assault, having suffered nearly 2,000 casualties in the landing, but they were alive, and they had broken through the Atlantic Wall. They expected to encounter retreating German forces, perhaps some hastily prepared defensive positions in the villages and towns inland. What they found instead was a landscape that seemed designed by nature itself to favour defenders and destroy attackers, a green maze that would prove more deadly than the German fortifications they had just overcome. Private James Henderson of the 26th Infantry Regiment wrote in his diary, that first day, a passage that would be discovered decades later in the National Archives. "We thought we were through the worst after the beach. We had beaten the Atlantic Wall. We had survived the worst that Hitler could throw at us. Then we came to these hedges, these damned Norman hedges. God help us all. The hedgerows were not hedges in any sense that American soldiers understood. They were not like the decorative shrub borders that Americans knew from suburban yards back home. They were not agricultural fencing that could be cut or pushed aside. They were ancient fortifications built up over centuries by Norman farmers who had shaped this landscape since the Middle Ages. The process had begun 1,000 years earlier when farmers cleared their fields of stones and rocks, piling them along property boundaries to mark ownership and create barriers for livestock. Generation after generation had added to these walls. More stones, more earth. Seeds from plants growing on top would fall and take root. Trees would sprout. Over centuries, the walls grew into earthen banks 3 to 12 feet high and 1 to 10 feet thick at the base. The soil composing these banks was packed hard as concrete, compacted by centuries of settling and reinforced by the root systems of the vegetation growing on top. On these earthen ramparts grew oak trees, hawthorn bushes, brambles, wild roses, and thorns that intertwined into barriers that rose 15 feet above the earthen base. The roots penetrated deep into the banks, some extending 10 or 15 feet down through the packed earth, creating a reinforced structure that was stronger than most man-made fortifications. These root systems were so dense, so thoroughly intertwined after centuries of growth, that the hedgerows could not be dug through without power tools, and could not be blown apart without massive explosive charges, that would reveal American positions to every German within miles. These hedgerows surrounded irregular fields that varied wildly in size, but averaged 200 to 400 yards across. Some fields were nearly square, others were long and narrow, some were triangular. The pattern was completely irregular, the product of 1,000 years of inheritance law, land division, and agricultural practice. Aerial photographs taken by reconnaissance aircraft in the weeks before D-Day had revealed the true scope of the problem. though intelligence officers had failed to appreciate its tactical significance. One photograph of the American sector covering just 8 square miles near Saint-Lô showed nearly 4,000 separate hedge-enclosed fields. Each field was a potential fortress. Each hedgerow formed a defensive wall, and there were thousands of them stretching across the entire American sector from the coast to the base of the Cotentin Peninsula and south towards Saint-Lô. For German defenders, every hedgerow was a ready-made defensive position superior to anything military engineers could construct. Machine gun teams could dig firing positions into the earthen banks, creating small apertures just large enough for the gun barrel that overlooked the open fields. These positions were invisible from more than a few yards away, protected from artillery by the earthen bank itself, immune to everything except a direct hit by a large-caliber shell. The vegetation on top provided perfect concealment from aerial observation. Spotter planes flying overhead saw only an unbroken canopy of green. The thick earthen banks protected soldiers from shell fragments and small arms fire. A German soldier crouched behind a hedgerow was safer than a soldier in a concrete pillbox because the pillbox could be identified and targeted while the hedgerow position was invisible until it opened fire. The tactical advantages for defenders were overwhelming. A single German squad, 8 or 9 men properly positioned behind a hedgerow with a machine gun and rifles, could cover an entire field and hold off an American company of 200 men for hours. The Germans did not need continuous defensive lines. They did not need to man every hedgerow. They simply positioned small groups throughout the bocage, creating a defense in depth where each position supported the others. When American forces attacked across a field, they faced fire not just from the hedgerow directly in front of them, but from hedgerows on their flanks, creating a crossfire that turned every field into a killing zone. American attackers faced tactical problems that were almost impossible to solve with available resources and doctrine. Infantry, attempting to cross the open fields, were completely exposed. There was no cover in the middle of a Norman field. No trees, no rocks, no depressions in the ground. Just open grass or crops with German machine guns and rifles covering every square yard from positions that could not be seen until they opened fire. The Germans had already registered their weapons on likely crossing points, marking ranges, calculating angles, preparing to deliver fire the instant American troops emerged from the previous hedgerow. Making the approach to the next hedgerow was a journey through pre-targeted killing zones where German gunners did not need to aim. They simply fired at predetermined points and hit whatever was there. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. The sunken lanes that connected the fields, worn deep into the earth by centuries of cart traffic, were equally deadly. These narrow passages, some barely wide enough for a single vehicle, were obvious routes for American advance and therefore obvious places for German ambush. The Germans would block the lanes with felled trees, rubble from destroyed carts, or simple piles of earth. Then they would position machine guns to cover the obstacles from concealed positions. American troops attempting to clear these lanes were channeled into narrow defiles, where a single machine gun could stop an entire platoon. And American tanks, the Sherman medium tanks that were supposed to be the key to mobile warfare and rapid exploitation, were neutralized completely by the bocage. The Sherman was a good tank by any reasonable standard. Its 75mm gun could destroy any German tank at normal combat ranges. It was reliable, easy to maintain, and produced in quantities that German industry could not match. American factories were building Shermans at a rate of more than 1,000 per month, but all these advantages meant nothing in the bocage, because Sherman tanks could not penetrate the hedgerows. The earthen banks were too thick, too solid, too heavily reinforced by root systems. A Sherman's 75mm gun could blow a hole in the vegetation on top, but that did not create a breach large enough for the tank to pass through. The earthen base remained intact. Tank commanders, frustrated and desperate, began attempting to breach obstacles by brute force. They would back up to get a running start, then accelerate directly at the hedgerow, attempting to use the tank's weight and power to smash through or climb over. This tactic was suicidal. When a Sherman attempted to ride up and over a hedgerow, the front of the tank would rise as it climbed the earthen bank. The tank would tilt backward at an angle of 30 or 40 degrees. This exposed the belly of the tank, the underside between the tracks, which was protected by only 1 inch of steel armor. This armor was designed merely to resist mine fragments, not to stop anti-tank weapons. A German soldier with a Panzerfaust, the shoulder-fired anti-tank rocket that was issued to German infantry by the thousands, could position himself in the next field and simply wait. He would hear the tank engine roaring as the Sherman climbed the hedgerow. He would see the front of the tank rise above the vegetation, and when the belly armor was exposed, he would fire. 1 rocket was usually sufficient. The Panzerfaust could penetrate nearly 6 inches of armor. Against the Sherman's 1-inch belly plate, it was devastatingly effective. Lieutenant Colonel Wesley Yale, commanding a tank battalion in the 2nd Armored Division, lost 4 Sherman tanks in a single morning attempting to breach hedgerows near the town of Iceni. 4 tanks destroyed, 4 crews killed or wounded, 16 men dead or injured, and not a single successful breach. His after-action report, filed on June 15th, captured the frustration and rage felt by every American armor officer in Normandy. The enemy need not even see our tanks to destroy them. They position themselves in the next field behind the next hedgerow and simply wait. They listen for the sound of our engines. They hear us climbing, the obstacle. And when we reach the top, when our belly is exposed, they fire. We are losing crews and machines to an enemy we never see, never engage, never have a chance to fight. Our tanks, which should be our greatest advantage, have become death traps in this cursed country. American forces tried every solution, their training and doctrine suggested. Combat engineers trained in demolitions and obstacle clearance were brought forward to blow gaps in the hedgerows using explosives. This technique worked technically. A properly placed charge of TNT or Composition C could blast a hole through even the thickest hedgerow, creating an opening large enough for a Sherman to pass through. But the tactic had fatal flaws. First, it was slow. Engineers had to move forward under fire, approach the hedgerow, place the charges, connect the detonators, retreat to a safe distance, and blow the charge. This process took 10 to 15 minutes under ideal conditions, longer under fire. Second, the explosions announced American intentions to every German within hearing, which in the relatively quiet Norman countryside meant every German within 2 or 3 miles. Enemy machine gunners and mortar teams would train their weapons on the gap before the smoke cleared. Third, American infantry and tanks advancing through these blown breaches were funneled into a single narrow opening that became a pre-targeted killing zone. German gunners did not need to search for targets. They simply fired at the gap and hit whatever came through. Specialized armored vehicles, particularly bulldozer tanks, proved little better. These were standard Sherman tanks fitted with heavy steel bulldozer blades on the front, designed originally for clearing beach obstacles during amphibious landings. In theory, these vehicles could push through or scrape aside the hedgerows, creating passages for following tanks. In practice, they became priority targets for German anti-tank gunners. The bulldozer tanks were slower than standard Shermans, less maneuverable, and highly conspicuous. German observers would identify them immediately and direct anti-tank fire at them, knowing that destroying the bulldozers would deny the Americans their primary means of breaching obstacles. The 79th Armored Division, which had landed in Normandy with 14 bulldozer tanks, lost 11 of them in the first 3 weeks of combat. By early July, American forces had virtually no bulldozer capacity left, and the few surviving vehicles were being hoarded for critical missions rather than routine hedgerow clearing. By late June 1944, 6 weeks after D-Day, the American advance had slowed to a nightmarish crawl, measured not in miles per day, but in yards per hour. The human cost was staggering and unsustainable. Official U.S. Army histories document that 8th Corps, advancing through the bocage toward La Haye-du-Puits and Lessay, suffered over 10,000 casualties while advancing approximately 7 miles. American infantry was dying at rates that rivaled or exceeded the worst battles of World War I. The capture of Mont Castre, a hill overlooking the Cotentin Peninsula, cost American forces approximately 5,000 casualties in brutal close-quarters fighting. The 1st Infantry Division, which had landed on Omaha Beach on D-Day, lost 75% of its frontline infantry in the first month of combat. Companies that had landed with 150 men were down to 30 or 40 effectives. The 29th Division suffered equally catastrophic losses. This was not mobile warfare. This was not the rapid exploitation that Allied planners had envisioned. This was attritional combat where every field had to be fought for, every hedgerow assaulted, every few hundred yards of ground purchased with American blood. And America, for all its industrial might and manpower reserves, could not sustain these casualty rates indefinitely. The replacement system was already strained. New soldiers arriving in Normandy were being rushed into combat with minimal training, thrown into veteran units to fill the gaps left by dead and wounded. Morale, which had been high after the successful D-Day landings, was declining rapidly. Soldiers who had survived the beach assault and thought they had faced the worst the war could offer were being broken by the grinding brutality of hedgerow combat. General Omar Nelson Bradley, commander of the 1st United States Army, faced a crisis that threatened not just his personal reputation, but the entire strategic plan for the invasion of Europe. His forces were exhausted, demoralized, and bleeding irreplaceable infantrymen at rates that could not be sustained. The British and Canadian forces to the east, fighting around the city of Caen, were making equally limited progress against heavy German armour. Field Marshal Montgomery's plan to seize Caen on D-Day had failed completely. The city would not fall until mid-July, more than a month behind schedule. The grand strategy that had guided 2 years of planning, the vision of rapid breakout and mobile warfare across France, was collapsing into the same kind of static trench warfare that had characterized the Western Front in World War I. Bradley's Chief of Staff, Major General Walter Bedell Smith, who also served as Eisenhower's Chief of Staff at Supreme Headquarters, described the situation in blunt terms that captured the growing sense of crisis. In a memorandum to Eisenhower, he wrote, "Every small field is a fortress, every hedgerow a German strongpoint. We are fighting World War I again, but this time the trenches are green and growing. Our advantages in mobility, armour, and firepower are negated by terrain. The Germans are trading space for casualties, and they are winning that exchange." The German defence of Normandy was brilliant in its simplicity and effectiveness. Rather than attempting to hold a continuous front line, which would have required more troops than they had available, German commanders positioned small groups of infantry throughout the bocage, using the natural fortifications to create a defence in depth that was nearly impossible to overcome with conventional tactics. A typical German defensive position in the bocage consisted of 2 or 3 machine gun teams, a mortar crew, and a handful of riflemen, perhaps 20 to 30 soldiers total. These small units would occupy a cluster of 3 or 4 hedgerows, positioning themselves to create interlocking fields of fire and mutually supporting positions. When American forces attacked, the Germans would hold their fire until the Americans were fully committed, emerging from cover and crossing the open fields. Then they would open fire with devastating effect. German machine guns, particularly the MG-42, which was capable of firing 1,200 rounds per minute, could scythe down entire American platoons in seconds. The Americans would take cover, call for artillery support, attempt to identify the German positions. By the time American artillery rounds began falling, the Germans would have already displaced to their alternate positions in the next hedgerow, leaving the Americans to attack empty positions, while German fire came from a completely different direction. German tactics exploited every advantage the terrain offered. Machine gunners would dig their firing positions deep into the hedgerow banks, creating small tunnels or caves that provided overhead protection from artillery and complete concealment from ground observation. The opening of the firing port would be just large enough for the machine gun barrel, perhaps 6 inches in diameter, camouflaged with cut vegetation that made it invisible from more than a few feet away. A German gunner could sit in complete safety, protected from everything except a direct hit by a large-caliber shell, and fire on American troops in the open field, with virtually no risk to himself. German snipers used the height advantage provided by trees growing on top of the hedgerows to observe American movements and pick off officers and non-commissioned officers. The loss of small unit leaders was particularly devastating to American forces. A rifle company that lost its experienced sergeants and lieutenants in the first few days of combat would be far less effective even if it received replacement officers, because the new leaders did not know the men, did not know who could be trusted in combat, did not have the bonds of mutual trust that held units together under fire. German snipers understood this and deliberately targeted anyone who appeared to be giving orders or carrying maps and radios. The Germans camouflaged their positions with extraordinary care and discipline. They would cut fresh branches every morning to replace wilting camouflage. They would cover the track marks left by their vehicles, sometimes going so far as to try to make flattened grass stand upright again. They dug tunnels under hedgerows to create protected routes for movement between defensive positions, allowing them to displace without being exposed to American fire. Some German units dug elaborate trench systems, connecting multiple hedgerows, creating underground networks that allowed them to move entire squads from position to position without ever being visible to American observers or spotter aircraft. The psychological impact of this combat on American troops was severe and cumulative. Men who had survived the horrors of Omaha Beach, who had faced German machine guns and artillery during the landing, who thought they had endured the worst combat imaginable, found the bocage even more terrifying. On the beach, at least the enemy was visible. You could see the German bunkers. You could identify targets. You knew where the fire was coming from. In the hedgerows, death came unseen from positions that could not be located until they opened. Fire. Every field was a potential killing ground. Every advance across open ground was a journey into terror, waiting for the moment when German machine guns would open fire and cut you down before you could react. Captain Joseph Ewing, serving with the 175th Infantry Regiment of the 29th Division, described the approach to Saint-Lô in terms that captured the suffocating claustrophobia of hedgerow combat. After the war, he wrote, "We advanced through a vast maze of natural fortifications miles in depth. Every hedgerow was a possible enemy position. Every field crossing was potentially fatal. We could not see more than one field ahead. We had no way of knowing where the Germans were until they opened fire. The tension, the constant awareness that at any moment machine gun fire might erupt from invisible positions, wore men down faster than actual combat. Veterans became hollow-eyed and shaking. New replacements broke under the strain within days. Into this desperate situation, where the entire Normandy campaign teetered on the edge of failure, where American casualties mounted by the thousands and no solution seemed possible, came an ordinary soldier with an extraordinary idea. Curtis Grubb Culin III was 29 years old in the summer of 1944, a sergeant serving with the 102nd Cavalry Reconnaissance Squadron, which was part of the 102nd Cavalry Group operating under the command of 5th Corps. He was nobody special in the vast hierarchy of the American Army. He held no advanced degrees, he had no engineering training. His background was utterly ordinary, the kind of American biography that was repeated millions of times across the armed forces. Culin was from Cranford, New Jersey, a small town about 15 miles west of New York City. His father worked as a salesman for a liquor distributor. Curtis had attended local public schools, graduating from Cranford High School in 1935. He had worked before the war as a sales promotion assistant for Shenley Industries, the same liquor company that employed his father. When the war came, he had enlisted in the New Jersey National Guard and been mobilized with his unit. He was trained as a tanker and driver. He knew how to maintain and operate a Sherman tank. He knew how to fight in armored combat, but he had no special technical expertise that would suggest he was about to solve a problem that had baffled the best minds in the American military establishment. What Curtis Culin had was something that could not be taught in any school or acquired through formal training. He had practical American ingenuity, the kind of problem-solving ability that came from growing up during the Great Depression when money was scarce and you learned to fix things yourself. to make do with whatever materials were available, to improvise solutions rather than waiting for someone else to solve your problems. This was a particularly American trait, born of a culture that valued individual initiative and practical results over formal credentials and theoretical knowledge. It was the same spirit that had driven American inventors and innovators for generations, from Benjamin Franklin experimenting with electricity to the Wright brothers building an airplane in a bicycle shop. In early July 1944, during a brief respite from combat operations, soldiers from Cullen's unit gathered in an informal group to discuss the Hedgerow problem. This was not an official meeting or planning session. It was just soldiers talking, sharing frustrations, venting anger about their situation. Tank crews, infantry, and officers all contributed to the conversation. They talked about friends who had been killed or wounded. They talked about tanks that had been destroyed attempting to breach hedgerows. They shared ideas, most of them impractical or impossible, about how to solve the problem. At some point in this discussion, a soldier made a suggestion that sounded to most of the group like a joke, or perhaps the ramblings of a man driven half-mad by combat stress. Military historian Max Hastings, in his book Overlord D-Day and the Battle for Normandy, published in 1984, identifies this soldier only as a Tennessee hillbilly named Roberts. Hastings provides no first name, no rank, no unit designation, no documentation. Despite extensive research by military historians in the decades since, no primary source has ever been found that verifies this man's identity or even confirms his existence. The account rests entirely on Hastings' single mention, possibly based on oral history or anecdotal information that cannot be verified. Nevertheless, according to Hastings, this soldier said something like, "Why don't we get some saw teeth and put them on the front of the tank and cut through these hedges?" Most of the soldiers listening laughed or dismissed the idea immediately. It sounded ridiculous. Saw teeth on a tank, like some kind of cartoon monster. But Curtis Coolin, sitting quietly in the group, did not laugh. He heard something in the suggestion that others missed. He recognized that beneath the crude phrasing was a mechanically sound principle. If tanks could not climb over hedgerows without exposing their vulnerable undersides, and if they could not punch through the solid earthen banks by brute force, then perhaps they could cut through them. Use the tank's own weight and power to drive steel blades through the base of the hedgerow, severing roots and penetrating earth like a plough cutting through tough soil. Coolin began thinking about the problem systematically. He envisioned a set of steel prongs or tusks projecting forward from the tank's hull. These prongs would need to be angled slightly downward so that when the tank drove into a hedgerow, they would bite into the earthen bank at ground level rather than riding up the face of the obstacle. As the tank continued forward with full engine power, the prongs would cut through the roots and earth, while the tank's weight kept it level and prevented the dangerous upward tilt that exposed the belly armor. The severed vegetation and earth would be pushed up and over the tank, but the tank itself would drive straight through the breach at ground level. The concept was simple, elegant, and achievable with available technology, but it required the right materials. The prongs needed to be strong enough to penetrate centuries of packed earth and dense root systems. They needed to be heavy enough to hold their position under stress, but not so heavy that they overloaded the tank suspension or reduced its mobility. They needed to be made from high-quality steel that would not bend or break under the enormous forces involved in cutting through a hedgerow. Where could such materials be found in Normandy in July 1944? The answer was literally lying on the beaches where the Räuber invasion had taken place 6 weeks earlier. Before D-Day, German engineers had installed thousands upon thousands of obstacles along the Normandy coast, creating a barrier system designed to destroy Allied landing craft before they could reach shore. Among the most common obstacles were devices called Czech hedgehogs, named for their resemblance to the anti-tank obstacles the Czech army had developed before the war. Each hedgehog was constructed from 3 steel I-beams, industrial-grade structural steel about 6 feet long, welded together at angles to form a 6-pointed obstacle that looked somewhat like a giant jack from a children's game. These hedgehogs were supposed to rip open the hulls of landing craft or provide anchor points for mines. In the event, The invasion had bypassed or destroyed most of them. Thousands of Czech hedgehogs now lay scattered along the invasion beaches, having failed to stop the Allied assault. They had been pushed aside by the landing forces, blown up by combat engineers, or simply bypassed. The steel beams, still intact and of excellent quality, were being collected in salvage yards behind the beaches, waiting to be shipped back to England for recycling. Here was exactly what Cullen needed: high-quality structural steel, already cut to convenient lengths, available in unlimited quantities. All he needed was permission to experiment and access to welding equipment. Getting approval from his immediate superiors proved surprisingly easy. Officers at every level of the American Army in Normandy were desperate for any solution to the Hedgerow problem. When Curtis Cullen approached his company commander with rough sketches and an explanation of his concept, including where he planned to source materials, the captain gave immediate approval. Within 48 hours, Cullen had been given access to a Sherman tank for experiments, welding equipment from the unit maintenance section, and authorization to organize a work party to retrieve steel beams from a salvage yard near Omaha Beach. The prototype took 3 days to construct in early July 1944. Cullen and his work party selected 4 sections of steel I-beam from the salvage yard, each approximately 5 feet long and weighing about 100 pounds. They used cutting torches to bevel the forward ends of the beams, creating angled cutting edges that would bite into earth and roots more effectively than blunt ends. They welded a horizontal crossbar to hold the 4 prongs in position, spacing them evenly across the width of the tank's front hull. Then they welded the entire assembly, prongs and crossbar together, to the lower front armor plate of the Sherman, positioning it so the prongs projected forward and angled slightly downward. The result was crude but functional. 4 steel tusks projecting forward from the tank's hull, angled downward at perhaps 10 degrees from horizontal, ready to be driven into a hedgerow. The assembly added about 400 pounds to the tank's weight, not enough to significantly affect performance, but enough to be noticeable. The prongs extended about 4 feet in front of the tank's normal profile, which meant drivers would need to be careful in close-quarters maneuvers. But if the device worked, these minor inconveniences would be more than justified. The first test was conducted on July 11, 1944, in a field near the town of Isigny-sur-Mer, several miles inland from Omaha Beach. A small group of perhaps 20 soldiers gathered to watch, mostly tankers and officers from Cullen's unit. Most of them expected another failure. They had seen too many proposed solutions to the Hedgerow problem, all of which had failed in one way or another. A tank with steel prongs welded to the front seemed unlikely to succeed where explosives and bulldozers had failed, but they were willing to watch, if only to be able to say they had been there when yet another crazy idea fell apart. The test, Hedgerow, was selected carefully. It needed to be representative of typical Norman bocage, not an unusually small or weak example that might give false results. The hedgerow they chose was about 4 feet high at the earthen base, topped with 15 feet of mature vegetation, including oak trees with trunks 4 or 5 inches in diameter. This was an average hedgerow, the kind American tankers encountered dozens of times every day. If Cullen's device could breach this obstacle, it could breach most of the hedgerows in Normandy. The Sherman tank backed up to give itself room to build speed. The driver, a corporal from Pennsylvania whose name has not been preserved in historical records, was understandably nervous. If the device failed, if the tank bellied up on the hedgerow as so many tanks had before, he and his crew might be the next casualties of the bocage. But he trusted Sergeant Cullen, who had explained the theory carefully and seemed confident it would work. The driver shifted into gear, advanced the throttle, and aimed directly at the hedgerow. 5 miles per hour. 8, 10. The tank hit the hedgerow with the prongs leading. There was a sound like heavy canvas tearing, a deep ripping noise as steel cut through earth and roots. The prongs bit into the earthen bank and penetrated deep. For a moment, it seemed the tank might stall, might be stopped by the resistance of the obstacle. Then the engine roar increased. The driver gave it full throttle. The tank's treads gripped the ground and pushed forward. Earth fountained up and over the tank's hull, blown upward by the force of the breach. Branches snapped, tree trunks splintered, vegetation showered down on the turret and rear deck. And then, less than 5 seconds after impact, the Sherman burst through to the other side of the hedgerow, trailing broken branches and torn roots, but otherwise completely undamaged. The tank had not climbed the obstacle. It had cut through at ground level, exactly as Cullen had predicted. The watching soldiers erupted in cheers and shouts. Some of them were crying, not from sadness, but from relief and hope. For 6 weeks they had watched friends die in futile attempts to breach these obstacles. For 6 weeks they had felt helpless against terrain that seemed unconquerable. Now, suddenly, impossibly, a simple device made from scrap metal had solved the problem. The tankers surrounded Cullen, shaking his hand, pounding his back, thanking him with a fervour that embarrassed the modest sergeant. Officers who had witnessed the test were already calculating implications. If this worked once, it could work again. If one tank could be modified, all tanks could be modified. If the device was as simple and quick to manufacture as it appeared, then perhaps the entire American armor force could be equipped before the planned offensive. But a single successful test, however dramatic, was not enough to transform the course of a military campaign. The device needed to prove itself in repeated trials under various conditions. More tests were conducted over the next 2 days, different hedgerows, different angles of approach, different speeds. Every test succeeded. The device worked reliably, predictably, safely. Tank crews quickly learned the optimal technique. Approach at 10 to 12 miles per hour. Aim directly at the hedgerow, not at an angle. Give full throttle at impact. The tank would shudder as the prongs bit into earth, but it would drive straight through without climbing or exposing its belly. Breaching time averaged 5 to 8 seconds from impact to emergence on the far side. Word of Cullen's invention spread rapidly through the 2nd Armoured Division and beyond. Within 3 days of the first successful test, Major General Edward Brooks, commanding the 2nd Armoured Division, had seen reports and requested a formal demonstration. Brooks was a competent, aggressive commander who understood armor tactics and recognized a breakthrough when he saw one. He immediately grasped the significance of Cullen's device and understood that it needed to be demonstrated to the one man whose approval and support could authorize mass production and force-wide implementation. On July 13th, General Brooks sent a message to 1st Army Headquarters, requesting that Lieutenant General Omar Bradley visit the 2nd Armoured Division area for a demonstration of a new hedgerow breaching device. Bradley, buried under reports and complaints about the stalled offensive, was initially skeptical. He had seen proposed solutions before, all of which had failed. But Brooks insisted this was different, and Bradley trusted his division commanders. He agreed to visit the following day, July 14th, 1944. The demonstration that opened this narrative took place that morning. Bradley arrived with his entourage, including Major General Leonard Garrow of 5th Corps and several ordnance specialists. 2 tanks had been prepared for demonstration. A light M5A1, Stuart tank, and a medium Sherman, both equipped with Cullen's device. The hedgerow selected for the demonstration was carefully chosen to be representative of typical bocage terrain. A 5-foot earthen bank topped with thick brush and mature trees, the kind of obstacle that had stopped American advances for 6 weeks. Bradley and his officers took up positions where they could observe clearly without being in danger if something went wrong. The light tank performed first, backing up to gain speed, then accelerating directly at the hedgerow. The impact, the sound of tearing earth and breaking roots, the fountain of dirt exploding upward, and then the tank bursting through in less than 5 seconds. Before anyone could react, the Sherman demonstrated the same capability with even more dramatic effect. Its greater weight and power drove through the obstacle like it was soft clay rather than a centuries-old earthen wall reinforced with tree roots. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.